It's nice to start off these things with a joke. I'm stealing this joke like a good engineer from a teaching expert that I like a lot, and he starts off and he grabs this big pitcher of water, and he says, "This is the professor, full of knowledge." And then he has a little cup. He says, "This is you." He says, "Here is the student, no knowledge yet. And here is the process of the university system." And he pours the water on the ground, it gets everywhere. And okay, yes, and it's very funny, but it's also funny because it's maybe a little bit true. I'm sure you've been in classes where the professor's kind of turning the crank. He's full of knowledge, but not very much of it is getting into the little cup. And you, as teaching assistants, can help get some of that valuable knowledge into the cup. Said another way, here's you. You are a graduate student at a prestigious research university. There's also at this university a bunch of undergrads. Ugh. And you're a teaching assistant. The professor has broadcast these lectures out into the world onto you and the students, and your job is to try to distill this knowledge, present it as valuable information, and get it into the heads of these poor undergraduates who are trying to get some bang for their buck, trying to get the most out of their college education. This is the challenge that we're faced with. So, toward that goal, I have 3 bullet points for you today. We're going to talk about how to prepare a lesson, how to teach the lesson, actually be up there and do stuff, and then figure out whether you were effective, or does this all mean anything, or did you actually achieve your goal of getting your knowledge into the kids? Okay, so each one of these things has 2 bullet points. The first one is, what are you going to teach? What material do you actually want to get into the students' heads? Sometimes if you're just the TA, the professor already has like a full idea, but even just figuring that out for yourself of what you want to get across in each lesson can really help you. And we'll do that with this thing called learning outcomes. Then, what's your plan? What are you going to do when you're up there in front of the students? What's your schedule of different topics? We'll make a lesson plan for that. Okay, so let's just talk about learning outcomes and lesson plans. So a learning outcome is nothing more than the following statement. By the end of this course, or chapter, or lesson, or day, or 50 minutes, clock's ticking, you, the student, will be able to blank. What is this blank? Well, here's an example from maybe a course on logic. Maybe in the syllabus, the professor would have written, by the end of this course, you will be able to manipulate the building blocks of logic with definitions, statements, and implications, and so on. By the end of this course, you'll be able to dissect an argument using formal logic. By the end of this course, you'll be able to recognize common logical fallacies. One way to think about this is, suppose you worked at a company and you were going to hire somebody and you needed them to do a bunch of logic. It would be nice if when they came in and you're like interviewing them, if you would actually be able to test them on these things. Hopefully anybody who's taken a logic course, if it's on their resume or whatever, would be able to do these things. These are all testable goals. And if you can think for your students what testable goals you would like them to learn, that will help you design the course, because then you'll be able to figure out whether or not, am I teaching them a testable goal, or am I teaching them some sort of fuzzy, weird, abstract thing that's not going to be on the test, so they won't even care? So it's important when you're writing these things out, when you're planning what you're going to say on your first day, if you could just figure out what specifically do I want the students to learn, to be able to do. What superpowers will they have earned by going to this class and coming and listening to me? So I just want a thumbs up or a thumbs down from everybody for, I'm going to present, 5 in order. I'm going to present 5, learning outcomes, and you can tell me whether you think they're good learning outcomes or not good learning outcomes. To have familiarity with the basics of probability theory. Thumbs up or thumbs down? Oh, come on, people. Yeah. All right. Somebody who said thumbs up. Why thumbs up? Please, thumbs up. Why? Mm-hmm. Yes. Okay, thumbs down. Somebody who said thumbs down. Please.
You said it should be testable.
Mm-hmm.
It's hard to define familiarity.
Yes. So I see the merits in both the thumbs up and the thumbs down. And by the way, this is not like, there's not some sort of objective metric. This is just, in my opinion, this could be a better learning outcome because it has to be really testable. So let me give you an example of one. So this is one that I would consider a pretty decent word problem. Oh, I gave you the answer already. Okay, thumbs up. So converting a word problem into a system of linear equations. Okay, that seems pretty good because that's exactly the kind of thing that you might want to cover in a 50-minute discussion section that the students could maybe learn how to do. They could learn how to convert word problems into systems of linear equations for the purposes of solving them for some linear algebra class. Okay, what about this one? I'm not giving you the one. Have an ability to program in MATLAB. Thumbs up or thumbs down? Okay, yeah, it looks like we're sort of converging on thumbs down. There's some middle thumbs there. Okay, but this was actually on the ABET syllabus, on the Accreditation Board of Engineering and Technology. This was actually on the ABET syllabus for our own class here at UCSB, a class that I taught. I did not want this to be there, because ability to program in MATLAB, what does that even mean? The students come in, they write hello world, they leave, like, all right, A+ for you. All right, so I think it should be more, you got to be more specific than this. If your professor said, oh, Justin, I would like you in your discussion section to teach the students how to have an ability to program in MATLAB, you would be absolutely lost. You would have no idea what to plan. So thumbs down for me on this one. How about this one? Do Bayesian updating with discrete priors to compute posterior distributions. Okay, we're getting some thumbs up. Okay, a lot of this is like, what? So this comes from an actual syllabus on the MIT OpenCourseware course for an introductory probability course. So they have some high-level goals, which are a little bit vague, but then they have what is the specific skills that you as a student are going to learn, and you can be sure the TA who is responsible for making sure that the students can do Bayesian updating with discrete priors to compute probability, blah, blah, you can be sure that there's a concrete way that they can present that information to have the students learn that specific skill. Okay, last one. Express a system of linear equations as a matrix equation. Thumbs up or thumbs down? Okay, pretty much thumbs up. Okay, it seems pretty clear. I bet you guys are getting the hang of this. It's testable. It's the kind of thing that the students would be expected to be able to do on a test. If your goal for what you want the students to be able to do is aligned with the test, everyone wins. That's what the students want, right? So you're in good shape. Okay, that's all I have to say on learning outcomes. Are there any questions on this? Okay. So let's talk about what are you going to do? What's your plan when you get up there in front of the students? What are you going to do for 15 minutes? Let's talk about how to make a lesson plan. This is pretty straightforward. It's just a schedule. It's just a little like spreadsheet where what are you going to talk about and when? What are you going to be doing? What are the students going to be doing? And what materials do you need to do it? So this is from a course that I taught. It's the Engineering 3. It's the Introductory Programming course in MATLAB. And in the second week, we talked about flow control in programming. So if statements, for loops, and so on. And I had written some files, some MATLAB files that I gave to the students that had some challenges in them. So I'll review the syntax, and I'll talk about the file. We'll do exercises from the files. The students will answer my questions as I challenge them, sort of in a Q&A format, and then they'll write some code. Okay? And then at the end here, I'll form the students into groups, and then the students will work in groups to solve some sort of challenge problem, and I'll have to write that challenge problem. So just getting a rough idea of what you're going to talk about will help you feel more confident when you go in there that you actually have something to say. And that can help the students also feel like all is well at the helm. Okay. Now, one important question is, what questions, there should be another column on here, which is, what questions are you going to ask them? How are you going to challenge them? So it's not, I mean, your discussion section shouldn't be just like another lecture where the students come in, they park, they log into Facebook, and then they zone out, you know? I mean, it would be nice if in discussion section could be a little more personable. You could like actually interact with them a little bit more. So here's an example. In this little, this section on if statements here, I have a Q&A question. So I was planning on, you know, I have the students have the file, have the code, and I'm saying, suppose you had a matrix A that was either 2 by 100 or 100 by 2, and you wanted to make sure that it was 2 by 100. Write the code to do this. So this is the kind of thing, this is not like, you know, rocket science for the students, and so I would give them maybe a minute or two to sort of figure it out, and then we'd start doing Q&A, and I'd say, okay, what did you get? Okay, maybe what line do I write next? Okay, what would you write, Stacy? What would you write, Alice? And so on. For the for loops, I would say something. So here's a question that I had for them, for the students. It was a 2-minute think, pair, share exercise. So what that is I give them a challenge. They work on it for a couple minutes. They pair up and share their answers with their partner, and then we all sort of reconvene and talk about it. So you know, I have a bunch of .mat files, like data files, represented as a cell array of strings. Write a loop to load all the MATLAB files. So this is some question that is very concrete. It's very clear. It's clear what the students should do. It's clear how long they have, and I will tell them, I'll remind them the format for how they should do it. So if you have this whole thing is like a very nice, well-contained, self-contained schedule for what your class would look like. Okay, so that's that. So A couple of tips when you're planning these lessons. So what are you going to put in the spreadsheet? Here's a couple of tips. Remember their incentives. So we were all students once, and the most important question, if you ever say to the students, "Do you have any questions?" Of course, the number one question in the back of their mind is going to be, "How will this help me get an A?" Students like it when they get A's, and they feel bad when they don't get A's, when they get a B+. So this is the motivating factor for most of your students, and the grade is a lever for you to use as an instructor to help them align their short-term goals of getting an A with the longer-term goal of actually learning the material. So how do you do that? Well, if you can make your content similar to the homework or the exam, something that is actually going to be graded, that will help them see the value because it's going to help them get an A. And here's one that you don't see very often. Is the discussion section graded? I don't know. I mean, it's like the classes are about to start, so I don't know how much you can negotiate with your professor. But if you can actually arrange to have the discussion sections graded a little bit, if some part of the grade for the students can be how you perform in the discussion section, that will actually get them motivated because they want to do well. Now, there's one caveat here. I really would not like the discussion section to be graded with just participation. I hate participation grades. It's just sort of a gimme. It's not really clear what that means. So, for example, one way that I like how this is done is Roger Friedman in the physics department has his discussion sections graded. The students come to discussion section. They work in groups. There are problems that are given to them that they work through that the TAs then collect in their little workbooks and they grade them, and the students know that they're graded on it. They got to show up, they got to do it. The TAs are there, so it's a nice safe area where they can ask for help from the TAs, but it is an important part of their grade. So the professor has signaled to the students, I really want you to do this because I'm grading you on it. So that's your lever, and even if you can't, well, okay, so here's a hypothetical tale of woe that happened to me where we didn't quite get the weightings right, and I want to challenge you. I want to ask you what you think about this. So, I taught a class a couple years ago. I taught this Engineering 3 class. We had a couple TAs. The TAs ran the discussion sections like this. They gave the students problems that were similar to the homework. That's good. It should help the students. The TAs then let the students work for a while. So, work with this, and then the TAs sort of go over the answers. If you were a student in this class, what would you guess would happen? Please.
You sit on Facebook for the first half and then pay attention to the answers.
Mm-hmm. Good undergraduate answer, yes. Yeah. Any other thoughts on how this might go down? I mean, this is what happened. The students realized, well, listen, all I have to do is wait around. The TA is going to tell me the answer to this fake problem. I'll figure out how to apply it to my real problem, my real graded homework problem, and Bob's your uncle. That's great. And so that's precisely what happened. So, you can't, this was by week 2 or 3, we were encountering this problem, and you can't go back and change the grade weightings. You can't say, oh, you know what, now it's 5% of your grade is coming to discussion section and doing these things. That's not fair to the students. The syllabus is like a contract that you give them on the first day, so that's unalterable. And so there's this question of how do you improve? How can you get the students to actually want to do some of this work, even if it's not graded? So let's talk about some ways to increase engagement. There's a few different ways. If you call on students, if you pick students to call on, you can do that. And there's this danger that you might start picking on people. So one thing to do that I've tried before is you just write everybody's name on a little card, on like a poker card, and then you can just sort of shuffle them and start picking it randomly. So you're like cold calling, but the students at least can see you're shuffling it. Hopefully not you're a card shark or something, but they can see that you're doing it randomly because you're trying to be fair. That's nice. The think, pair, share thing we talked about, you can have students sort of group up, work on their own, and then share it with their partner. This is used, Roger Friedman in the physics department does this really cool thing where he uses these eye clickers. People heard of, everybody heard of an eye clicker? Okay, some people haven't heard of an eye clicker. It's essentially a remote control. The students all have to buy them. Woo! All right. The students all have to buy them for various classes. And the idea is you, as the instructor, have a little receiver that's plugged into your computer. You can open a poll. You present them with a question. You open the poll. The students, it's like multiple choice. The students figure out what their answer is. They click the little button, A, B, C, D, E. And then you can like show histograms of the answers and so on. What Roger Friedman does is he has the students figure out, they do the problem on their own. How fast is the block going to fall down the inclined plane or whatever? A, B, C, C, D, E. The students then share their answers. Maybe the answers are different than your partner. Then you've got some skin in the game. You have to defend your answer. That's where the real learning happens. And then you vote again. Roger Friedman shows sort of the before histogram, how many students did A, B, C, and D, and then the after histogram. He says it's most interesting when there's this sort of a bimodal distribution. You've got a bunch of students who said A and a bunch of students who said C. Suddenly there's like, War of the Worlds, it's like a tribal thing all of a sudden. But then you can talk about it. The idea is that students are kind of engaged there. So there's this fear. So there's some ideas for how you can get a little bit more engagement in your classes. Now there's this fear that if I do these things, I will have to stop standing at the front of the room talking and they're all listening to me. I will have to relinquish control to my students. I will have to lose control over my classroom. If I start to do that, it could be anarchy, it could be chaos, it could be things could be on fire, people could be taking selfies, anything could happen. What I want to encourage you with is there is a way to release control to the students that will not result in anything being caught on fire. The way is this: if you can just present the activity with a specific goal, we are now going to solve this particular problem. I'm going to give you a specific start and stop signal. I'm going to tell you when to start, and when I clap a couple of times, I'd like everybody to sort of stop talking, and we'll come back and we'll resume the class. And I'm going to give you a couple minutes to do it. So everybody knows sort of here's the rules of the game. You've programmed into the activity an end goal, a termination condition, so that you can resume control of your classroom. And this is a way that it can be very effective. Nothing has to be burning up or no selfies have to be taken. Okay, so that's all I have to say on preparing a lesson. You can write down where you want to go, essentially, with the learning outcomes, and what are you going to say with the lesson plans, and some ideas to increase engagement. Next, we're going to talk about how to teach it. What are you going to do when you're actually up there in front of everybody? Everyone's looking at you. All your students are judging you. They're all staring at you. And how can you handle that? You're going to probably have to write on a board at some point. So we'll talk about some good board work. And then how can you solicit questions from the students in a way that actually gets them thinking instead of just picking random numbers. Okay, so I'm actually going to tell you how not to write on a board. I'm going to do this in the following way. My friend Dustin is going to come in here. On your handouts, does anybody need a handout? Hopefully everybody has a handout. Okay, very good. Are there any more handouts? I printed Okay, if you don't have a handout. Okay, they're back there? All right, send them on up. All right, and so maybe you can just pair up, because this is not super critical, but pair up with somebody if, yeah. So my friend Dustin is going to come in here. My name's Justin. He's Dustin. He's going to come in. Yeah, we see where this is going. You call it, yeah. He's going to do a problem. He's going to do the physics problem. I would like you not to do the problem, but to write down sort of what went well and what went poorly. Okay? Any questions on this? If not, I'll go get Dustin, okay? I guarantee none of the other sections. Oh, what's going on? All right, so how are you all doing? Okay. All right, so welcome to, what is this, physics? Okay, welcome to physics. We're going to do a physics problem here. Okay, so here's the problem. Trinity jumps off a freeway overpass and hopes to land on a truck below. She is running 10 meters per second, jumps horizontally. The truck's driving at 30 meters per second. She's 5 meters above the truck when it happened. Question 1, when should she jump? Specifically, how many seconds before the truck passes her and the jumping off point should she jump? Question 2, when she lands on the truck, how fast is the truck going relative to her? Okay, so let's do this. This is from The Matrix. Maybe you saw this movie. I love this movie. Okay. Yeah. All right. So here we go. Part A. Number A. Trinity is going at 10. There's a truck going at 30. All right. There's some height. It's 5. Okay. So what is the equation for one-dimensional motion? Right, okay, it's x equals x naught plus v naught t plus 1/2 at squared, right? Okay, this is obvious, right? This is not rocket science. Okay, so then essentially you just plug it in. All right, so you got a 5 here, you got a 5 here. Actually, no, you got a 0 here. Okay, right? You got a 10 here. You plug this thing in. What is this? This is 0. Sorry, it's -5. Okay, and you get 10 t. All right, this is gravity, right? So this is actually 10. Am I saying right? Okay, 10.8. All right, and then it's 9.8 over 2 t squared. You solve for t. What do you get? You get 10 over 9.8. You know what? I'm sorry. This is actually, no, this is a plus. Okay. And you get, what is it? It's 1.0101525545. All right. Now this is going to be on the midterm, so I hope you got all these significant digits. All right. Good. So that's the answer to problem 1. When should she jump? This far. This is in seconds. Problem B. Number B. All right. So when she lands on it, where's this problem? When she lands on it, how fast is the truck going relative to her? Okay, this is easy because it's vectors, right? You guys know vectors. It's the velocity of Trinity minus the velocity of the truck. Okay, this is the 2 norm. Maybe it's the infinity norm. You guys are going to learn all this stuff. It's really easy, but okay, it's the 1 norm. Who knows? Okay, so this is, what do you have here? It's the vectors. It's a 10 minus 9.9. All right, okay, here we go. Minus the 30 and the 0. Oh my God, okay. And what is this? You do some more math here. I think you got to plug in one of these things. Ah, yes, so this thing is 9.9 comes from the V equals AT, okay? And that's just minus 9.8 times the T. The T comes from here. You plug this in and you get 22.316133766. And this is in meters in seconds. Meters per second because the problem's in metric. Okay, are there any questions about this? Okay, great. So the midterm's tomorrow, and good luck with everything. Okay. Was he that good? Was he really that good? So, how did it go? All right. Oh, Dustin. So maybe you can help me list down some things that he did well and probably more things that he did poorly. Let me see if I can get this thing up here. Oh, Dustin. Ah, yes. Don't read these magical secret notes. Let's see. Very good. So, you don't have to say what he did well, what it is. Just fire him off. Anybody have any idea, any thoughts? Entertaining. Hey, that's a point for Dustin. All right. Okay. Please, someone else. Please.
Leave the questions up on the board ahead of time.
He put the questions up ahead of time? That seems like a good thing. Is that what you have? Good thing? Okay. Problem up on the board.
Good handwriting.
Really? Okay. I'm going to put that in as under sarcasm. Okay. Okay, please.
You don't specify in the problem which direction the truck's going if it coming towards you.
Ah, yes, he certainly didn't do that.
You also can't jump horizontally.
Yes. We've got a lot of really good ones. Okay. Yeah, that's true. It would be sort of more of a sort of. Okay. Any more? What else? Please.
Wasn't very engaging.
Not engaging. Mm-hmm. How was he not engaging?
Well, we just went up there and wrote a bunch of stuff down. He didn't really ask any students any questions. He didn't ask for any feedback. Mm-hmm. Kind of like, all right, this is on your midterm, so gotta know these numbers. It
might as well have been a YouTube lecture, and a bad one. Yeah. What else, please?
So choosing variables. Yeah.
Yes, the variable names. T is for Trinity, and P is also for. I cannot. Yeah. Yes, exactly. Okay. Others, please.
He said a lot. This is easy. This isn't rocket science, which trivializes if anyone's having problems with it.
Mm-hmm.
And they're not math questions.
Yes. Yes, it can kind of be tough on students. In fact, I did this. I did this the first one of my first lectures. I said, hey, this isn't rocket science, because I was trying to tell the students, don't be scared. This isn't supposed to be a super hard thing. But then my other instructor came up to me and he said, quantum mechanics kids, if they don't get it, it really hurts to hear that. Please.
When reading out the problem, then go through and basically lay out what they're Yeah.
So poor problem layout. Yeah. what vars are given. Okay, yes, please.
Yeah, board work is probably good to give examples of like how graded work is expected to look. So I'll write a lot of units in this. It's small, it doesn't have like a logical flow of work.
Sure.
So if you could provide a better example for how a professor would expect it to read, you really do better.
Yep. Okay, please.
Kind of related to that, but just ridiculous sig figs.
Yep. Please. And then you.
He didn't really explain why he's doing a lot of stuff. He was just like, well, you should kind of know this already. So it was going to get a good explain why. Spend all the time writing rather than and just getting it done with. That's the attitude. So.
Yeah.
Wrap it up.
Yeah, so it's like he doesn't even want to be here. Yeah. Please.
Skipping math steps is like the biggest part of doing
Yeah, he skipped a lot of steps. Yep, exactly. Please.
So if you miss something and you look at the board, you can't really tell what was the reasoning.
Yeah, no, this is
Steps.
Yeah, the skipping steps, and there's no reasoning. Exactly. There's no writing here besides just the math. Yeah. Reasoning. Okay. Please, in the back.
Yeah, and also the part of substantial explaining of when relations they're actually valid or not, or what the conditions are.
Yeah, here's just a random equation, and he didn't even let you provide it. He just said, oh yeah, here we go. You have no idea what is the name of this equation and when is it valid. Yeah, absolutely. Yep.
Yeah.
More, please.
You brought glasses to the class, so there's no eye contact, right?
Yep. He was just too cool for school. Okay. And now you're all wondering what's he going to do. I'm just going to go over here. We're going to sort of, we're going to take over the good, because, okay, please, there's somebody over here?
Yeah, so they didn't really finish the problem board like that. I mean, that T is like a G is right or whatever. Like, that's how you know your board answer. So, like, if the student like, didn't follow the picture, like, it's still possible.
Yep, exactly. It's really not clear, and somebody else mentioned this is a similar thing. It's not clear, what are we trying to get? How do we know when we're done? Yeah. So, like, the ending conditions. I'll fix that in post. Okay. Anything else, please?
There's still one with engagement, but the pacing was way too fast. Like, you didn't really take any time to get feedback from the student. When we asked for questions, there was no time.
Yep. No more questions. Okay, cool. Please.
Kind of going off of that, like as soon as he posted up the question, he'd go right in. He didn't give them any chance to actually contemplate or think about this.
Others? Anything more? This is a pretty good list. This is all going to be on the net too. So.
Okay, the value is not that critical to this problem. Like you give so many digits after the point.
Yeah.
However, actually, the key point is how you reason, how you like using the formula or equation. So you miss the point.
Yes. How to use the equations. Okay. Final thoughts? Cool. Okay. Thank you for helping me with criticizing my friend Dustin. And yeah, these are all really good things. And he was entertaining. That was good. So good job, Dustin. Okay, so that's all I want to say on good board work. Is you've seen an example of how it's done poorly, and hopefully some of that can stick in your mind. Something that Dustin meant to do more. I'm not sure if you noticed this, but he had his back to the board. And that can be tough because his body is blocking it, and also like he's not really engaging with you. So that's something that I struggled with for a long time is having my back to the board. And it's not until I did this like TA consultation thing that you can all do if you want, where they film you and then an instructional developer talks with you and watches the video. Not the whole video, but you can learn a little bit about your own teaching, your own things that you can work on in your own teaching, and that can be very helpful. Okay, so let's talk about how to ask effective questions, how to solicit questions from the students in a way that actually causes them to engage their brains and not just sort of randomly guess. So I have a longer list that I will give you shortly, but before then, I just want to go through a few of the highlights. So, and some of these are obvious, some of these are a little more touchy-feely. So if you ask it's good to ask the question, and then if you're going to call on somebody, call on them. Because if you say, okay, Jeff, what is the equation for a one-dimensional motion with constant acceleration? As soon as you say, okay, Jeff, everybody else is like, oh, poor Jeff. Good luck, Jeff. They can just kind of check out. So it's nice if you say the question and then the name so that everybody knows that they're sort of on the hook. And that kind of works with the random card thing, too. If your questions are short and clear with clear, specific answers, students will be more likely to give you their best guess at them. I'm sure you've had, as a bad example, I'm sure you've had professors who are going through this and they say, okay, great, so we've got this, what do we do next? It's like, well, what do you mean next? I mean, we get lunch is what I'm going to do next. The professors clearly have a next step in mind. They clearly have the right answer for what they would do next. But if you're not the professor, it's not clear what the scope of the word next is here. So it's nice if the answers are clear, sort of like, okay, so at this point, we'll plug it in and we'll apply the, equation, we'll solve for t. Who can tell me the equation, what happens if you solve this equation for t? That's a very clear, distinct answer. There's no sort of funny business about it. Another one is this business about waiting. Dustin did not wait at all for questions. He just sort of blew right through. And the students will learn that when you ask a question, you're not actually asking them a question. They don't actually have to turn on their brains because it's just sort of a rhetorical question. It's kind of a rhetorical device. It's nice to give clear start and stop signals. We talked about that with the engagement thing. If they talk quietly, you can sort of back up a little bit and say, I'm sorry, can you say that again? And that just backing up will kind of give them a little subtle clue that maybe they should speak up again. It's kind of a subliminal manipulation thing. That can work. And also, I want to just talk about, speaking of manipulating people's psychologies, I want to point out that something that can help is dressing up. You and your students are pretty close in age. You're certainly closer to them than the professors. The professors are totally, incomprehensible because they're so old. But so you need some way to establish with your students that I'm very much like you, and that's a good thing. I can empathize with you. I can talk about your problems. I can help you with this. I'm very much like you, but I am the instructor here. You don't want the students being like, oh, can I please turn this in late, or can I get some more credit on this, or whatever. You don't want them dogging you for random points. You don't want them nickel and diming you. And by just dressing up, it sends a subtle signal that I'm dressed up because I'm the instructor here. And it just establishes, I'm not saying that it's good to manipulate people, but it just sends a signal that, there is a difference, and I need your respect. Okay, so that's my plug for manipulating people. Okay. And the last one that I want to talk about here is allow passing. So I call on Jeff, say, Jeff, what do you think the answer to this thing is? He says, oh, I don't know. Now I can either drill into Jeff and really make him suffer, because I think he's on Facebook. But it's a little bit nicer if you say, okay, Jeff, that's okay. I'll come back to you later. Then Jeff knows, and the rest of the class, by the way, because they're seeing this, Jeff knows I can pass, but I can't get a free pass. It's going to come back to haunt me later. And then everybody else knows that, if they say pass, they're not going to get out of it entirely. Okay. Now, similarly about the drilling into Jeff thing, please don't use your questions, your position of authority, to trick, trap, or punish students. The students will all learn very quickly if you start using your position of authority to question a single student over and over again, that you are using questioning as a weapon against them, and you could just as easily use it as a weapon against you, or you, or you. They'll kind of resent you for it, and that will damage your ability to run the class well. And then the last one, this is a minor point, is yes-no questions really provide literally one bit of information. Any other form of questioning that can make the students have to provide a richer answer can give you better insight into whether they actually understand it or not. Okay, so with this in mind, please take just 3 minutes. On the other side of the handout page, there's an asking effective questions, and I would like you to improve those questions. So there's a quick back and forth with the professor and some students, and please just take 3 minutes, ding, 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 okay? And then we'll reconvene. I'll clap my hands or something, okay? Great. And then we'll reconvene. If you don't have a handout, please you can just collaborate with your partner, and we'll talk about it. Thank you very much. Okay, in the interest of time, let's start going through them and free to finish up. So number 1, Tom, what is the equation for the pitches of a particle under constant acceleration? Thoughts on this? Please. Yes. As soon as you say Tom, everybody else checks out. Okay, so number 2, reads the question prompt. So what's the first step? Thoughts? Please. Yes, it's vague, and it would be nice to have a little time. Number 3. Okay, so how do I sum the numbers from 1 to 100? This isn't rocket science. Yep. You idiots. So now we have the velocities and the initial positions of the particles. What can we do with those? Or how can this be applied to the equation? The question is sort of too vague. Other ideas? Number 5. So what is the particle in free fall?
Yes or no question.
Yeah, it's kind of a binary question. Yeah. Here's an easy one. The question asks for the tension in the rope due to blah, 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 blah. How do we start? Well, that's easy. The question is just centripetal acceleration, blah. Okay. Thoughts?
Let them answer it.
Let them answer it. Thoughts? Yeah. It's too easy. Yeah, exactly. Okay. Number 7. Okay, teacher says a question. Jeff says, arctan of x over y. No, that's wrong. Try again. Okay. Okay. Yeah. So it's poor practice. How would you improve it? How would you say it?
Why is he wrong? Like, try to explain why is he wrong.
Yeah. In fact, a very useful tool in this kind of situation is to say, Jeff. Yes, my good friend Jeff. Jeff, that would be the correct answer if the question were, what is the sign of the angle or something? Sort of help them out a little bit. Say, okay, that's not quite what I was looking for, but it's what in some sort of parallel universe, some other version of me would have wanted. So, okay, number 8. Teacher says, blah, blah. What's the expression of the angle? Jeff tries to pass. Okay, how about you, Diane? Improve.
Let them off too easy.
Let them off too easy. Yeah, gotta hook them somehow. Okay, very good. Other thoughts on any of these? Okay. Did I just pause enough time? Should I really wait for 10 seconds? Should I practice what I preach? Yeah, very good. Okay, so we're on to the last section. How are you going to figure out whether or not you've made a difference to these budding young engineers and students? There's essentially 2 things. Give feedback to them, and there's a lot of ways you can give feedback, but the one I want to talk about is how to do that in Gaucho space, sort of programmatically, and because this is kind of a cool tech tip. And can you get feedback from them? How can you solicit feedback so that if you yourself are screwing up somehow, you can actually make it a little bit better for everybody? So, with the feedback, giving useful feedback is probably sort of best done if the student seeks you out, is in a receptive frame of mind, says, I'm having trouble with this part of the homework, can you help me? You sit down one-on-one, you sort of probe around, you can see kind of what they understand, what they don't understand, you can help them out. Pinpoint what they're struggling with and help them out. You have a zillion students, so unless they come to you individually, which they will, and that's nice, how can you help the most students sort of on average? And here's a tip. In Gaucho space, when you grade students' homework, there's a feedback form that you can put in. Now, it's a pain in the neck to fill this out for every student. So there's a couple of ways that you can speed this up a little bit. Here's one of them. You can actually, in Gaucho space, download, for each assignment, you can download a blank Excel spreadsheet that you can fill in. You can fill in the feedback thing, and then when you're done, you upload it back to Gaucho space, and it populates it for you. That can be pretty easy because you'll find that students typically screw up the same kinds of things. There's going to be one thing where they all forgot to do this one thing, and you're going to deduct 5 points from that. So in some other spreadsheet here, you can also have sort of a little rubric that you've made of when they make this kind of mistake, I take away this many points. And here's the comment for that. So then you just paste it right in, and the students can get the feedback that they need. It's a lot nicer for them than just missing a bunch of points. Will they actually look at it? I hope so. But the fact is that it's easy for you to do it if you kind of use the copy and paste it into the spreadsheet, and it could help them out. Another thing on the rubrics is if they're working on a bigger project, and this is something we did in like ECE 147C, the controls lab course, they have to write a big report. How do they know what goes in the report? Well, we give them this rubric. We say, okay, in the abstract section, I want you to talk about this. In the intro section, I want you to talk about this. You have a brief description of blah, blah, blah. And then we tell them how many points it is total. And then when we fill them in, after they turn in their reports, we fill in the comments and give it back to them with their grades. So the point is that they were informed consumers. From the very start, they knew what we wanted to get. And that makes everybody happier. And it also reduces workload on you, because you don't have students coming and say, why did I miss 3 points on this? You can point right there. Okay. So, oh, and sorry, one more thing on this. You can, if you don't want to do this, is a lot of work. The minimal thing that you can do to reduce the danger from students coming to you asking for regrades is you can just have as you're grading your big stack of papers, you can have a separate sheet of paper where every time you take off points for this problem 3 or whatever, you just jot down what the problem was and how many points I took off for it. And that means you can be consistent. The next time the student makes a mistake, you can look back on your little piece of scratch paper. And that will help you when the students come back and they say, why did I lose 3 points for this? You can say, well, I did it for everybody. Look. Okay, so what about getting feedback from students? I have a couple of things on this. One is, at the very beginning of the course, if this is your first time TAing especially, you might like to know where you stand. What are your students like? You can give them an entrance survey. You can ask them just a few questions. What year are you in college? Have you ever programmed before? We gave a programming class, so we were interested in knowing whether students had programmed before. And we were very interested to know that even though this was a super introductory programming class, so that about half of our students were in the freshman summer start program, we also had a bunch of students who were years 2, 3, and 4. They were much older, and they were in other disciplines, not just engineering. So that was very useful for us to know sort of what we were up against, what sort of experience our students had. Same with programming before. Most of the freshman students had never programmed before, but a few had. A few were like the superstar computer scientists, and a few of the non-first year students had never programmed before. Okay, well that's fine, so that we sort of know how to tune the lessons going forward. So that's the entrance survey. Another thing you can do, like every week, is just pass out a bunch of note cards and say, I want to know what's your year and major, what's going well in the course, what are you enjoying, and what needs improvement? What could we improve on that would make your experience a little bit better, that would help your learning? This can be super helpful. So we did this once toward the beginning of the class, and I gave them a bunch of in-class exercises. I said, hey guys, what do you think about the in-class exercises? Do you want more or less? Are you okay? And I was amazed to learn that not only the freshman summer start program kids, but also the older students, they both wanted more in-class exercises. I thought these students just wanted to sit back, kick back, go on Facebook, and sort of listen to me drone in the background, but they actually wanted to work. They wanted more engaging things to work on. They didn't just want to listen to me yammer on. I thought that was so cool. So I did. I cranked up the number of in-class exercises, and a couple weeks later, I asked them again, and they still wanted more. I was like, these kids are gluttons for punishment. Will they ever stop? But I think they actually, I was positive. I was trying to, I always kept in the forefront of my mind, I'm teaching you this because it's going to be valuable for your future careers. And I think that really clicked with them. I think they really knew that it was going to be valuable if they worked on it in the class. So that was really heartening. It was great for me. It was great for them. The feedback cards also have, free response. And so this is a word cloud of their responses. So here's the thing where they wanted more in-class examples. But I also wanted other stuff too. So sometimes I go too slow through the examples. Okay, homework 1 was hard. Yeah, that's true. It was a little bit hard. Okay, I can't compete with classmates with programming experience. Wow, okay, yeah, that's true. Some of the students are superstars, and some of them are taking the class again because they failed it the first time. They got to take it during the summer. They'll fall back in the curriculum. Okay, so this is a concern that some of the students have. This is your conduit to learn how your students are doing, and you can really benefit from that information. That can be very valuable. Much more than just figuring out if half of them failed the midterm. Okay, so that's it. We have 3 seconds left, so I will pass out. Please fill out your evaluations, and I will pass out the last handout with all the answers and links to more resources. And I wish you the best of luck in your TAing your class and inspiring the future generations. Yes. Say again? Okay. We need the attendance sheet. Please send it up here, and then everybody who didn't sign it can get them up. But I will send out these things. Thanks for your attention. Thank you very much.